All right, let's go ahead and let's see. Let's share. We are going to share this one and this one. I think that'll work. Let's share the two. Oh no. Let's go like this so we're not showing that information. All right, and one other stop. Yeah, here. This one is real low. All right, greetings YouTube. Beautiful Mind here, aka Professor Pfeiffer. Let me see. Let's hop. Let me see. We're gonna hop over. We're gonna hop over here for right now. Oh no, nope. Oh, should be. Where's my image? It is there. Okay. Okay. Let's see if there are any major announcements. No major announcements. This is what, week 5. So, again, exam 1 was due, so that's kind of old news. Exam 2, we can anticipate that at the end of March, right? So that last week of March, we'll be looking for exam 2, and then the final will be that first week of May, right? So I think last time we finished out section 1.5, right? So today and tomorrow, we're going to be doing like lab work, like things that I consider to be our lab work. So it's basically like factoring review. Again, this is asynchronous, so the main thing, is just check in. This is not optional, but just check in. So if you're in my Zoom right now, you've already got your attendance credit for the day. You don't have to stay, but I do need people to check in. Be sure to be getting your questions answered. You ask any whatever questions you want to ask and get them answered. Now is the best time. My original intent is, again, for this period to be a study session, for, let's say, like a Q&A. But I just typically go through the homework to fill the space. Our lectures are pre-recorded, and I can't think of anything else. Just kind of keep up with the assignments in Pearson. Also, be sure to take advantage of the tutors. The tutoring, you've already paid for tutoring. It's included in your tuition. And we have tutors. We have people just like waiting to help, right? So just take advantage of it. You know what I mean? Closed mouth don't get fed. You got to speak up. Okay. So that's really it. I can't think of anything else. Other than that, I'm going to go ahead and hop over to Pearson. We're just going to kind of continue working. So again, these are linked into our Blackboard. I'm actually going to skip this first question. How quickly can I do it? I'm going to hit continue. Let me just hit continue. I don't think there's anything to fill in. Type the number 1. I'm just curious what it does. Check, keep going. Continue. I just want to get to the next one. Click the icon and click, type the number 3. Okay, that's interesting. Okay, so let's see what we're working with today. So like that first question, it has to come from our book. So I just chose the first question. So this is going to be more practicing with factoring. Today, the factoring concept, we're going to be solving equations using the zero factor property, right? And these concepts, so again, the setup of our class, this is supposed to be a lab, right? And so this is like college algebra with lab. And so the intent or the idea was that, okay, maybe if we have more meeting times, like on a weekly basis, we don't have to jam so much information into like 2 sessions per week. And so with the extra sessions, that'll give us an opportunity to kind of like fill in any gaps, holes, or places where we might be lacking. So that's why I keep including all this factoring thing, because for college algebra in general, like nationwide, worldwide, whatever, it's expected that we're already comfortable with factoring, right? So, but I know that most college algebra students are not comfortable with factoring. So then I was like, okay, well, what makes sense is let the lab be practicing with factoring. Also, we can talk about any assignment that you have access to. We can talk about it during class. Like if you want me to pull it up, if you want me to go over your question specifically, I would make use of the Ask My Instructor tool. It's like if you go here to Question Help and click on the Ask My Instructor. It's like if you can't get it, between you and your peers can't get it, and if the tutor can't get it, that's when the Ask My Instructor is ideal. And like we can either talk about it during class, or I might make a dedicated video, but I would recommend that. Okay, factor by grouping, right? So when we have 4 or more terms, did I load that document? I'll check it later. When we have 4 or more terms, we might try grouping and factor. Let me write this one out because I feel like it's going to be too much to explain audibly. Okay, So give me a moment to take some notes and then we'll hop over to the tablet. So let's see, this is, I still like to do my header. This is week 5, even though it's typed. Oh no, are you doing that thing? Let me reboot you, because I know how you like to do that thing. Hopefully you'll behave. It's like, man, my equipment has been acting up. I've been trying to like get set up for like the past 30 minutes and then it like crashed on me. I was like, okay. I just did woosah. It just started setting everything back up again. I had to, you know how equipment can be. Okay, so it seems like it's behaving okay. This is week 5. This is actually day number 19, Captain's log, right? Solving equations using the zero factor property. Solving equations, let's do it like this. Equations using the zero factor property. And I hope everyone is doing well. Property. Cause like here in Atlanta, the weather is actually pretty decent. The weather's nice. I mean, you know, I don't know what everybody else is experiencing. I know at one point it seemed like the whole country was like in snow except for Georgia and Florida. So, and power, all this crazy stuff. Anyway, this is question number 2. This comes from an alternate text or alternate book. Okay, so it's not from our usual book. And then it's asking us to factor by grouping. And again, we use this technique when we're trying to factor a polynomial that has 4 or more terms. So we have this SC plus SZ plus NC plus NZ. Man, that's like a tongue twister. Okay, let's hop over to the tablet. Let me make sure it's showing there. That looks good. Okay. So this is the essential information from that question, right? So like if we group, so let's group the first 2 together. Now, what do the first 2 have in common? Honestly, we could use the box method here. So they both have a S. So we can factor out S from both of them. And what's left over? We're going to be left with C plus Z. That's not a plus. C plus Z, right? So the hint when you're doing factor by grouping, you kind of anticipate, oh, we're looking for another C plus Z on the right-hand side. So if we look at the 2 on the right, what do they have in common? So they both have N. We can factor out N from both of them, right? Okay. So if we factor out the N, what's left is C plus Z. So now, with the 2 main terms, they have a common binomial factor. So that's basically the blue thing. What do these 2 terms have in common? They both have the blue thing. So let's factor out the blue thing, which is C plus Z. I don't know why I can't write my pluses today. C plus Z. And that leaves us with S plus N, right? So my claim is that this is the factor form of the original, okay? So again, this is called factor by grouping. We use it when we have 4 or more terms, okay? So then I'm just gonna hop back over to Pearson and submit this result. So we got C plus Z and S plus N. Okay, I'm gonna check, enter for the next question, okay? That's fine. All right. So let's see, factor the trinomial. Let me take some notes. So this is question number 3. I'm gonna say factor. We got 3m cubed minus 9m squared minus 54m, right? Let me hop over to the tablet so you can see what I'm doing, okay? So what do they all have in common? First question we ask ourselves is there a greatest common factor? We can factor out 3m from all terms, right? What does that leave us with? That leaves us with m squared minus 3m minus, let me see, there's a 124 is what, 8? 18, right? Then it looks like we could factor that further. We're looking for 2 numbers that multiply to give us negative 18 and add to give us 3. what was it, 6 and 3? So negative 6 and 3. Okay. So then this factors into the following. We got m, ones plus, ones minus, negative 6, and a positive 3. M times m is m squared. Outer negative 6m plus 3m is a negative 3m. And then last times last, 3 times negative 6 is negative 18. Okay. So this is, I'm going to go with this. Can I paste? No. I'm going to go like this. Okay. Copy. Okay. Let's hop over to Pearson. It's not prime. So then we have 3m parentheses m plus 3 parentheses m minus 6. Okay. Next question. I think I might be able to just do this one off the cuff. So this is difference of squares. So normally you got something squared minus something squared. So it's going to be c squared minus 9 times c squared plus 9, right? But then we got difference of squares again here, right? C squared minus 9 factors into c minus 3 times c plus 3. Yeah, no, c plus 3, right? And I think that's it. There's no sum of squares. Okay. We got 4 more terms, so I would do factor by grouping. Let me write this one out. This is question number 5. We're going to say factor. Of course. So we got, let's see, c squared minus 2c plus 1. I see. That's difference of squares. We would get c minus 2. That's not going to show up there. Okay. Plus 1 minus 64q squared. Okay. So if we hop over here, so then I would still do factor by grouping, but instead of doing 2 and 2, I'm going to look at the first 3, right? Can we factor the first 3? I think it's a perfect square trinomial. So it factors into c minus 1 quantity squared minus 64q squared, right? So now at this point is difference of squares. We got something squared minus something squared. So this factors into c minus 1 minus aq and c minus 1 plus aq. Okay. Okay. Let's just copy that. Okay. So we're going to submit that and keep it moving. Parentheses c minus 1 minus aq parentheses c minus 1 plus aq. Okay. Let me check. Next. Okay. Okay, so this one, we can already see the common binomial factor, so we can go ahead and factor it out. Common binomial factor is c minus 2, and what's left is r plus z. R plus z. Okay. Let's see. Let me write this one out. Okay. So this is question number 7. I'm going to say it's an alternate text or alternate book. Okay. We're asked to factor. We got kq minus 12q plus kr minus 12r. Okay. Let's hop over to the tablet and see what we're working on. All right. 4 or more terms. So I would do factor by grouping. All right, I'm going to look at the first two and second two. The first two, what do the first two have in common? They both have Q. And what's left over is going to be K minus 12. The hint is we're looking for another K minus 12 on the right-hand side. What can we factor out of the two on the right? We can factor out R. And notice it leaves us with K minus 12. Now, what do these two terms have in common? They both have the blue thing in common, so we can factor that out. And then that leaves us with Q plus R, right? Paste. Okay. Okay, let's go with this. Here, and like this. So then we're going to say K minus 12, Q plus R. All right, on to the next one. Solve, okay. So let me take some notes here. This is question number 8 from this assignment. I'm going to say solve. This comes from an alternate book. We have this 2x squared plus 16x equals 0. I'm going to hop over here. So first let's factor. It does have a GCF. We can factor out 2. We can divide both sides by 2. We'll get, let me see, does that help us? Actually, let's factor out, I'm just going to factor out 2x on both terms. If we factor out 2x, this leaves us with x plus 8 equals 0. So then when we have 2 or more things that multiply to give us 0, we can use the zero factor property. That means basically set each thing to 0 and solve. So either we set 2x equal to 0 or x plus 8 equal to 0 and solve, right? On the first one, if we divide by 2, x equals 0 or x equals negative 8, okay? So both of these will make the original thing 0. So that's a demo on the zero factor property. Okay, let's hop over to Pearson. So we got 0 and negative 8. I'm going to do negative 8 comma 0. Boom, next question. Okay, solve. Let me see, if we divide both sides by negative 5, we're going to get y squared minus 4. So then plus or minus 2, right? So minus 2 and positive 2. Okay. I would expand this out. Let's write this all the way out. Let me see the time. Okay, so this is question number 10. We are like moving and cruising, okay? All right, number 10, solve the equation. So we got this x plus 2 times x plus 2 equals 1, okay? Let's hop over to the tablet and let's see what's going on. I was going to expand it out, but actually we can do the following. I'm going to try the following technique. So we got something squared, right? So we can rewrite this as x plus 2 squared equals 1, right? We can use the square root property, so we can take the square root on both sides. We're going to get x plus 2 equals plus or minus square root of 1, all right? But square root of 1 is just itself, so I'm just going to say plus or minus 1 there. I took the square root on both sides, okay? And then if you subtract 2, x equals negative 2 plus or minus 1, right? So then x equals negative 3 or negative 1, okay? Now we should check by plugging these into the original. Things like this, we can actually check by plugging into the original. Like when x is negative 3, negative 1 times negative 1 is positive 1. When x is negative 1, 1 times 1 is 1, right? I'm gonna hop over to Pearson. We got negative 3 and negative 1. Negative 3 and negative 1, okay? Next. So basically here, zero factor property, when things multiply to give you zero, you set each thing to zero and solve. So we'll get -7 and 6. -7 and 6, those two will make the original 0. All right, I'm going to write this one out. This is question number 12. So question 12, we want to, this comes from an alternate text, alternate book. We're asked to solve. We have 5y plus 3, y plus 3, -5, 5y plus 3. Okay. Let's hop over to the tablet. Okay. So let me see. I think first I'm going to set it equal to 0. So I'm going to move the thing on the right to the left. Yeah. So I'm going to leave it as 5y plus 3 times y plus 3 plus 5 times 5y plus 3 equals 0. Notice both terms have the 5y plus 3, so let's factor that out. We can factor out the 5y plus 3, and it's going to leave us with y plus 3 plus 5 equals 0. Okay, so zero factor property, you set each thing to 0 and solve. 5y plus 3 equals 0, or y plus 8 equals 0. Subtract and divide, y equals -3 by 5. Y equals -8. I'm just going to trust it. I'm not going to check it just because we're on the computer, right? But if I wanted to get a sense of, if I wanted to check it, I would plug these into the original and make sure that they work. Okay, but I'm just going to submit them into the computer. So let's see, we get a -3 by 5, and we get -8. Let's see what happens. Okay. All right. I'm going to go into the next question. Let's see. Okay. Solve the equation. Let me do something really quickly. Go here. So these are the ones I heard from. Let me hit absent, 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 absent. Okay. These are no-shows. So I'm going to let that be. Hop back over here. That looks healthy. Solve the equation. Let's see. We can factor it out. Y squared. Two numbers that multiply to give us 60. Hang on. I think I might be able to do this in my head. Looks like 0 is one of our answers. So we have y squared. So 6 and 10, right? No. Yeah. -6 and -10. So then 6 and 10. I'm gonna just do 6 and 10 and see what happens. Okay. All right, I'm just gonna move forward. Let's see. I would do factor by grouping here because we have 4 more terms. I'm gonna write this one out though. This is question number 14. All right, you're doing that thing? Okay, let me reboot you. Hopefully we didn't lose like a bunch of work, because it is infamous for that. All right, I think we're here. All right, yeah, we did the last one. Okay, so this is question number 14. I'm going to say it comes from an alternate text or alternate book. We're asked to solve. We have x cubed plus x squared minus 4x minus 4 equals 0. Okay, we're going to hop over here. I'm going to assume that that's working properly. Let me make sure I'm still streaming at least. The stream looks healthy. All right, I'm going to study that. Okay. So we have 4 more terms. So I'm going to use the technique of factor by grouping. I'm going to group the first 2, right? If I look at the first 2, what can we factor out of the first 2? We have x squared, and we're left with x plus 1, right? So the hint is we're looking for another x plus 1 on the right, right? What can we factor out of the 2 on the right? It looks like -4. And I think indeed we're left with the x plus 1 equals 0, right? Notice, if we distribute, negative 4 times x is negative 4x. Negative 4 times 1 is negative 4, right? So that checks out. So now we can factor out the common binomial factor, namely the blue thing. They both have the blue thing, right? And this leaves us with x squared minus 4 equals 0. And then, but we can go further because we have difference of squares. So the blue thing comes down. X squared minus 4 factors into x minus 2 times x plus 2, okay? So then I think we get plus or minus 2 and negative 1. Okay, actually I like that. Let's copy that. Okay. All right. And again, if I were like on paper or not on the computer or something like that, I would plug these into the original to check, but for the sake of time, I'm just going to do this, this, and this. Okay. This one, okay. So what I would do here, I'm going to use a technique called U-Substitution. So let me take some notes first. This is question 15. Again, this comes from an alternate text or alternate book. We're asked to solve. Now we have this 4 times x minus 1 squared minus 4 times x minus 1 minus 3 equals 0, okay? So then what I would do here, I'm going to use a technique called U-Substitution. I'm going to say let u equal this x minus 1, that term. So I'm going to replace all of these x minus 1s. I'm going to replace them with u, right? So this is going to transform into the following. We got 4u squared minus 4u minus 3 equals 0. Okay, this should look familiar. Like we should be able to factor this. Okay, we're looking for two numbers that multiply to give us negative 12. All right, negative 12 from here and here. Okay, and we're going to stop at the line that adds up to negative 4. The factors of negative 12 is what, 4 times 3? So negative 2 times 2 times 3. We're going to stop at the line that gives us negative 4. So first we can do negative 1 and 12. That adds up to 11. So those are not the two numbers we're looking for. We can do 2 and 6. This adds up to positive 4, but we want negative 4. So these are not the two. So we're just going to switch the signs, 2 and negative 6. Okay. These are the two numbers, right? I'm a fan of using the box method. So I'm going to use the box method to finish this out. Thank you. Hello phone. Let's stop. Okay, I'm using the box method. So in the upper left hand corner goes that leading term, the 4u squared. Okay. The bottom right is the constant. It's negative 3. And I'm going to rewrite this middle term using, no, not that color. Using the two numbers that we just found. Okay. And again, these are the two that we want. So we're going to do negative 6u and plus 2u, right? So if we look at the two on top, what do the two on top have in common? Here, let's do it like this. What do these two have in common? We can factor out what? 2u. What about the two on the bottom? They both have negative 3. What about the two on the left? 2u, okay? 2u. And these don't have anything in common, so we're going to say plus 1, right? So the claim, let me get a copy. So my claim is that, this guy right here, copy. My claim is that this actually factors into 2u minus 3 times 2u plus 1. Okay. And let's do a quick check. Notice that 2 times 2 is 4u squared, so that checks out. 2u minus 6u is a negative 4u, so that checks out. And then negative 3 times 1 is negative 3, right? So then now we can use the zero factor property. So again, this stuff is like, to me, it's not obvious. It's not trivial. Even if you've been exposed to it, you're just gonna need practice. I don't know, because we don't use it in the everyday life, right? But it's there. And so like going forward, you kind of gotta, you need to be comfortable with stuff like this going forward. Even if you're like, I know most college algebra students, not all, but a good amount of college algebra students, like, you know, they don't go into like math or the sciences. Some do go into the sciences, but a lot don't. And yeah, you know, I know you're not going to use this, but my struggle, okay, so now I'm thinking about the questions like, well, why are we learning this if we're not going to use it? So then to me, what it says is like, it just shows that you're versatile. You know how to get things done. Even though, hey, this is not my forte, I'm intelligent, I'm strong, I'm versatile, I'm determined, you know, I'm savvy, right? And so just do what you got to do to get through this. And then on the other side, you get your degree. I don't want to be like, you're never going to see it again, because it does keep popping up. I've had so many students leave, and then they say they'll come back and say when they went to apply for a job, the first thing that they gave them was a math exam. So it's like people that know this in conjunction with whatever the task is, they get, that kind of elevates them a little bit or whatever. But, you know, honestly, if it were up to me, I wouldn't make people study things. Like, if they don't think it's important, I wouldn't make them study it. And, like, not until they see the value. And I know maybe that's because I'm, like, maybe a little bit young and I don't have children, you know, because it's trying to get children to do things that they don't see the value in. But, you know, what can I tell them? I don't know anybody else. It's like people use it, and people, like, powerful people use it, but everybody doesn't use it. So it's like, to expect everybody to be powerful, that's not, you know, it's not, I don't really recommend that for everybody. I recommend it for like those that like want to become scientists and like build and like, you know, like create stuff like this. You know, I would just say, just let them do it. But that's neither here nor there. But I enjoy it. I'm glad that I got access to it. So I'm going to keep kind of doing it. Anyway, and I'm talking about like math. So we got the zero factor property. Two things multiply to give us 0. So then, let's see. So we're going to have 2u minus 3 equals 0, or 2u plus 1 equals 0. Add and divide, u equals 3 by 2, or subtract and divide, u equals a negative 1 by 2, right? So then I think originally we said let u equal x minus 1. So now we're going to have x minus 1 equals 3 halves, or x minus 1 equals a negative 1 half, right? So if we add 1, that becomes 5 by 2, or add 1, x equals, so 2 by 2 minus 1 is 1 by 2. Okay. So again, like if I were, oops, let's undo. If I were like working on paper, I would plug these into the original. That's not going to work for me. Let me go like this, like this. I want to copy that and expand it. Okay. I will plug it into the original to make sure that they work. I'm just going to use Pearson. So let's hop over here. Pearson is this way. Yeah, I think we're okay. So 5 by 2, and the other one is a half. Okay. Let me see the time. Okay. We'll go to the next question. How many? Oh, we got a good amount. We got like 5 more. Okay, let me write this one out. This is an interesting one. So this is question number 16. It comes from an alternate text or alternate book. We're asked to solve. We have this 4x minus 3 squared equals 25x squared, right? Okay. So I'm going to set this as 0 and solve. So I'm going to subtract the right from both sides. We're going to get 4x minus 3 squared minus 25x squared, okay? All right. So we can use difference of squares. We got something squared minus something squared. So this should factor into 4x minus 3 minus 5x times 4x minus 3 plus 5x equals 0. Okay, let's simplify some. 4 minus 5 is a negative. Negative x minus 3. 9x, right? 9x minus 3. In that first term, we can actually... I'm going to go with it. It's fine for right now. So we have two things that multiply to give us 0. So then basically this negative x minus 3 equals 0, or 9x minus 3 equals 0. Okay. If we solve, x equals negative 3, or we add and divide, x equals 1/3. Okay. Let's paste. Again, if I were on paper, I would plug these into the original to make sure it works. But because of the setup, I'm going to just plug it into Pearson. Okay. We got negative 3. Trying to see if I missed anything. Or 1/3. That's my time. Okay. Okay, it says, oh, I like these. These are fun. Okay, this is question... I mean, I could screenshot, but that's gonna like mess stuff up. I'll probably do better writing it out. This is question 17. Comes from an alternate book. Alternate book. Okay. Ooh. It's a word problem. It says, actually, I kind of want to type it. Let me just type it out. Let me be uniform. I'll just take my time. So it says a farmer has 400 feet of fencing, okay, and wants to enclose, let me see, and wants to enclose a rectangular area, of 5,100, that's not a, 5,100 square feet. Let me move that to the next line. 5,100 square feet. Okay. What dimensions should she use? What dimensions should she use? Okay. Question mark. Cool beans. Okay. Let's hop over to the tablet. All right. So a farmer has 400 feet of fencing and wants to enclose a rectangular area of 5,100 feet. Okay. So the basic shape here is a rectangle. So let's start with the rectangle. Matter of fact, we got one loaded. And because we're doing a farm and a farm is luscious, we're going to go like this. All right. And on top of that, I'm going to fill my grass with this. Actually, I don't like that. Let me undo. I'll do this. Oh, what is that? Oh, you're doing that thing again? Why? Why? Why are you doing that? You're going to make me like redo all this, aren't you? Let me see. Yeah, it's lagging. Is it doing that if I do this? No. This one? Yep. All right, let me not, I was going to fill it in, but I'm a little nervous. Because it's kind of like acting up. Anyway, okay. So she has 400 feet of fencing, and she wants to enclose a rectangular area of this amount. What dimensions, right? So we have a rectangle, so we're going to be looking at the length times the width, right? So the amount of fence she has is 400, so that means the perimeter, right? So the perimeter of a rectangle is going to be twice the width plus twice the length equals 400. And then the area is 5,100 square feet. So that means length times width is going to be 5,100, okay? So we have two equations, two unknowns we can solve. Let's see. So if we solve for, like, let's solve for W in the second equation. If we get the, let's solve for L. If we get the L by itself, then L is going to be equal to 5,100 divided by W, right? Then we can take this and substitute this into the first equation. So we get 2W plus 2 times L, but L in this case is 5,100 divided by W equals 400, okay? So now I'm going to clear up my fractions. I'm going to multiply all terms by W. So I'm going to say this times W, this times W, and this times W, right? So then what it'll give us, I basically said the left and the right by W, right? So then what happens is we'll get 2W squared plus, what is that, 10,200? 10,200 W. No, that W is gone because it cancels. This cancels this. I'm going to say minus, well here, equals 400 W. And then now I'm going to set everything to 0. So then we get 2W squared minus 400 W plus 10,200 equals 0. We can factor out, we can divide both sides by 2, right? This will give us W squared minus 200W plus 5,100 equals 0. Let's see, can we find two numbers that multiply to give us 5,100 and add to give us 200? So let me go through the factors. It should go quick. Hopefully it goes quick. 5,100. That's what, 51 times 100? 51, 3. Hey Siri, what's 51 divided by 3?
51 divided by 3 is 17.
100 is 10 times 10. So that's going to be 2 times 2 times 3 times 5 times 5 and 17. I think those are all the factors, right? Let me check real quick. Hey Siri, what's 2 times 2 times 3 times 5 times 5 times 17? Oh, okay, let's try that again. I had an alarm go off. Let me see. Hey Siri, what's 2 times 2 times 3 times 5 times 5 times 17?
2 times
Cool
2
beans.
times 3 times 5 times 5 times 17.
All right.
5,100.
I'm going to go on a journey of going through all these factors, but I'm going to stop at the line that adds up to negative 200. All right? Okay. So first you have 1 and 5,100, but that adds up to 5,101, so those are not the two. If we do 2, now look, if we use a 2, what's left over? Let's see. We got a 10, we got a 15, so that's 115. That's 150 times 17. Hey Siri, what's 150? Cancel.
1 over 5 is 0.2.
6 times 25. Let me see. If you have 6 quarters, what is that? $1.50. So 150 times 17. Hey Siri, what's 150 times 17?
150 times 17 is 2,550.
2250, 2550. Okay, but these are not the two numbers, right? We're already halfway there. We can do 3 because we got 3 in our list, right? So if we use this 3, 25 times 4 is 100, so it looks like 1,700. Okay. Nope, not that color. 1700, but these are not the two numbers we're looking for either. Okay. We can do 4 because we have a 4 right here. If we do 4, we got 75 times 17. Let me see, 30, 50, let me see. 30 plus 21 is 51. So if we have 51 quarters, how much money is that? What's 4 into 52? There's a 112, so 13, so 4 into 52 would be what? 12? I'm trying to do too much in my head. If you have 51 quarters, if you have 50 quarters, how much is that? Well, 5 quarters would be 125, so that's 1250. I think it's just 1250. If we have 50 quarters, 125, 1250, so 1250 plus 25, there it is, so 1275. Okay, I think that's the number. Anyway, just playing around. I think we said 1275. Let me see. I'm gonna use Siri real quick. Hey Siri, what's 3 times 5 times 5 times 17?
3 times 5 times 5 times
Okay.
17 is 1,275.
Let's keep going. The number is coming down quickly. We're looking for 200. That was 4. We can do 5. This will probably be it for the day. So if we do 5, let's see, 10 times 6 is 60. So 6 times 17 would be 60, 36, 42. So 42 plus 60 is 102, so 1020. This one should be 1020. Okay. So I'm just practicing. Like, there is a technique that's called, like, if you go on YouTube and do a search for like human calculator, like I think it's like number theory. Basically, you can like crunch a whole bunch of like huge numbers like really fast in your head. Like, there are people, like, honestly, one of the professors, I don't know if he's still at Morehouse, but when I was a student, he did a showcase and he was able to get those results faster than we can type it in a calculator. Like, people would call off random stuff and he can get the answer faster than you can type it in a calculator. I don't know the usefulness of it, but I'm sure it's useful. But it was just like, it's kind of like a game. It's kind of fun. Let's look at let's go to number 6. Okay. If we use 6, 25 times 2 is 50. So 5 times 17 would be 50 plus 35 is 85. So 850. So this should be 850. I'm going to put a cross next to that. Okay. We don't have 7. Can we do 8? We can't do 8. We can't do 9, but we can do 10. All right, we can do 10. 10 is going to be basically this guy is gone and this guy is gone. So we got 30. 30 times 17 is, let me see, it's a 30 plus 21, 51. So 510. We're almost there. And again, we're just doing this by hand. Let's see, I'm going to check this with Siri. This is gone. This is gone. Hey Siri, what's 2 times 3 times 5 times 17?
2 times 3 times 5 times 17 is 510.
Okay, we're almost there. That's 10. We can't do 11. We can do 12 though. We have a 12. 12 is here. So if we use that already, 25 times 17, we have 17 quarters. If we had 16 quarters, that would be like $4. So then 425. This is going to be 425. We're almost there. But these are not the two numbers we're looking for. 12, we can't do 13, we can't do 14, we can do 15. Okay. Say these have been used. 4 times 5 is 20. So 30, 32, 34. So 340, right? 340. We're almost there. Let's keep going. These are not the two. We can't do 16. We can do 17. I feel like, well, no, we're not there yet. But we can do 17. Now, if we do 17, this guy is gone. 4 times 25 is 100, so that's 300. Almost there. Okay, let's keep going. Can we do 18? I'm going to just kind of go back up to the top. 18 will be 6 and 3. We can't do 18. We can't do 19. Can we do 20? We can do 20. So now if we do 20, 20 is going to entail this one. These two are gone, and one of these is gone. 15 times 17. Hey Siri, what's 15 times 17?
15 times 17 is 255.
Okay, we're almost there. These are not the two. Then we do 21, 22, 23, 24. 24 would be what, 8, 24. We can do 25. Okay. So if we use these two 5s, 12 times 17. Hey Siri, what's 12 times 17?
12 times 17 is 204.
Oh, I didn't even think about that. Okay, so 204. Did we miss something? Because now we're past, now, oh, no, we're okay. That's fine. No, we're okay. We're at 229. We're almost there. 25, 26, 27, 28, 29, 30. 30 would be what, 3 times 10? Yeah, these two. So we can do 30 right here. Okay, so if we do 30, what's left over? 10 times 17 is 170. Yep, I think those were the two. That was an adventure. All right, those are the two numbers we were looking for, 30 and 170. Okay, so with that being the case, our claim is that this w squared minus 200w plus 5100, okay, our claim is that that can factor into w minus and minus. It should be minus 30 and minus 170. Let's check those numbers real quick. So w times w is w squared, so that checks out. Negative 170 plus negative 30 is a negative 200, so that checks out. And then negative 30 times negative 170. Hey Siri, what's negative 30 times negative 170?
Negative 30 times negative 170 is 5,100.
All right, so zero factor property. So then we set each thing to 0 and solve. W could be either 30 or 170. Okay. I think if W is 30, let me see. A farmer has 400 feet of fencing. So let me see. If we let W, suppose W was equal to, we said what, 30? Suppose we let W be 30. Okay. Hey Siri, what's 5100 divided by 30?
5,100 divided by 30 is 170.
Then the length, right? So those are the dimensions, right? Hey Siri, what's 2 times 30 plus 2 times 170?
2 times 30 plus 2 times 170 is 400.
Okay, so these are basically the dimensions. It needs to be 30 by 170, and you can actually flip them. We're just gonna match however the question is requesting it. Let's put you there. Let's put you there. And we're gonna put you here. Okay. That was an adventure. Okay, let's hop over to Pearson. We're gonna submit this and we're gonna call it a day. Let me go like this. I'm gonna go paper, and I'm gonna kind of work simultaneously. So while I'm loading this, while I'm checking Pearson, I'm gonna go ahead and load this to. I'm gonna go ahead and load a copy of this for you guys. I want to send it to Box, not Business Cal. This is the spring. This is college algebra notes. This is fine, and it can go right there. Okay. So the long side of the fence and the shorter side. So we got 170 for the long side, feet, and we got 30 for the shorter side and feet. Okay, let's check our answer. Okay, I'm gonna actually stop there. That's a good stopping point. Okay, let me hop back over. So I did load a copy. I did make this available. We're gonna hop back over to Pearson. To my tablet. If we can get it to show. Okay. It's doing that thing again. Come on. Why? Why are you doing this? Let me see if I do this. Sometimes this will do it. All right, I'm gonna just let you be. Let's see. Come on. That's good enough. Okay. Yeah, I can't really think of any other major announcements. So, we went on a little adventure. We're actually gonna end the session here. And just be sure to hopefully you guys are making your way through this. Nobody really asks me questions, but that's generally how it goes. And I know that COVID kind of made it worse. So I was like, well, it is what it is. I'm not gonna study it. I'm just gonna be available and try to cover my tracks because I can't make you do anything. I can only set the stage, right? I'm not trying to do anything. I'm just trying to be available and help you on your way. That's how it always is. But the pave to hell is paved with good intentions. So that's usually how that goes for me. But that's neither here nor there. Yeah, I can't think of anything else. So on that note, we're actually going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.